Hey everyone, Math 6, we are now in Chapter 8, talking about surface area and volume. So today we're on Unit 8.1, three-dimensional figures. So we're going to talk about all these sorts of things, what they are, parts of them, and yeah, it'll be a good time. So, a couple definitions here. Solid is a 3D figure that encloses a space. So 3D, what's that mean? Three-dimensional, okay? So something with height, with width, and with depth. So, you know, if I can draw here. Oh, that's not going to help. Excuse my very quick drawing. But, you know, if that was a cube, then that would be a 3D figure. How about a cylinder, right? 3D figure. Pyramid. 3D figure. So yeah, a solid is a 3D figure that encloses a space. So those are all solids. A polygon, what is a polygon? Well, it's a 2D closed plane figure with at least 3 straight sides. So polygon. Polygon's even simpler than a solid because it's only 2D instead of being 3D. So what's an example of a polygon? Well, at least 3 straight sides. So how about a triangle? It's a polygon. About square. That's a bad square. My apologies. How about a rectangle? Okay, polygons, right? At least 3 straight sides. So is a circle a polygon? No, a circle is not a polygon. No straight sides there. All right, and then lastly, let's talk about a polyhedron. Polyhedron is a type of solid, so a type of one of these, where or whose faces, so the sides you could kind of think of, are all polygons, right? So is a sphere, and it's kind of, I'm not great at drawing a sphere. Pretend that's, it's a sphere. It's a basketball. Yeah. It's a basketball. Is that a polyhedron? No. Okay. Why? Because the face of a basketball, well, it's not a polygon, right? Because it's not 3 straight sides, right? But how about a triangle? So that's a polygon, but a polyhedron would be a triangular prism. So that's a triangular prism, and it's a type of polyhedron. So we'll talk more about that. All right, so we're going to talk about some components of polyhedron, or polyhedra would be the plural of polyhedron. So we have a face. So what is the face? The face is just a flat surface of a polyhedron, right? So this right here would be, well, I should probably do that in red, There we go. So that's a face, okay? Flat surface of a polyhedron. Now an edge, pretty self-explanatory. It's just a line segment where 2 faces intersect. Okay, so the definition you may not, know right off the top of your head yet, but what's if you bump your head on the edge of a table versus the corner of a table? Okay, the edge is where 2 parts of the table would meet. Okay, and so what 2 faces are intersecting to form this edge right here? What 2 faces would intersect? Well, those 2 faces would be this one here, and then this one over here. Again, they intersect along this edge. And then lastly, vertex, super easy. A point where 3 or more edges intersect. So if you got this edge, and this edge all coming in there, intersecting right there at that vertex. All right, so I want you to try this. Pause the video, find the number of faces, edges, and vertices of that polyhedron, and then play it when you're done. Let's see how you do. All right, so faces. How many faces do we have? Well, we have this one on top. We have this one right here. We have on the bottom and on the back side, so that's 4, and that's getting messy now, sorry. And then we have the kind of right side over here and the left side. So I would say that is 6. All right, so for edges, let's count these. We've got 1, 2, 3, and 4. 5, 6, 7, and 8. And we have 9, 10, 11, and 12. So there are 12 edges there. And then lastly, we'll count our vertices. So 3 edges intersecting. So there's 1. Same thing there. 2, 3, and 4. 5, 6, 7, and 8. So there you go. Hopefully you got that. If not, that's okay. But make sure you know that before you come to class. So next, let's talk about the 2 main polyhedra we're going to be talking about, and that is prisms and pyramids in this unit. So let's talk first about pyramids. So what's a pyramid? It's a polyhedron that has one base, right here, and the lateral faces are all triangles. Okay, so you can see that very easily. If that was made of cardboard and you could unfold it, you would see a square. It looks like a square. We'll just assume it's a square right now. Base, and then you would see 4 triangles unfold off of that. Now we have a prism here which has 2 parallel bases, okay? So, and they're identical. So the lateral faces are parallelograms. So what does that mean? Well, let's talk about the 2 parallel identical bases. So we see in green these highlighted, and those are our bases, and they are parallel to each other, meaning if you were to kind of lay a ruler on top of that base, and it was like a long ruler and it extended off, and then like the same thing here, they would never intersect. They would never like kind of go, well, this one's coming here, and then this one comes off here, and then they hit. That's not the case, okay? They never intersect. They're perfectly parallel to each other. There's 2 of them. And then the lateral faces, meaning the other faces, the non-bases, are also parallelograms. So we have like a rectangle here in the front. It's not a base, at least in this case of the way it's oriented, and but it's still a parallelogram, in this case a rectangle. So there's the difference, pretty easy. And then we're going to talk more about this in class, identifying these, but we have a row of prisms and then a row of pyramids here, and we can learn to identify them based on their bases. So do you have an idea maybe what this first one is? Think about it. What would it be? Well, we know it's a prism because there are 2 bases, and it would be a triangular prism. Okay, how about the next one? Prism, right? And it looks like there's a square in front, so we could call it a square prism. Although if you were to kind of, if you were able to actually take that object and kind of move it with your hand, you would maybe make it look more like this one here, and then turn it up like that. And we would call it a rectangular prism. So it really depends. Now, rectangular prism is never wrong for this, okay? Because a square, even if we say the bases are square, what's a square? It's a type of rectangle anyway. Next is definitely a rectangular prism. Now, how about the next couple? Think about those 3 real quick. Did you get that right? Pentagonal. What about the next one? Hexagonal. And then lastly, octagonal, right? Stop sign. All prisms. Why are they called what they are? Because pentagonal, hexagonal, octagonal, rectangle, square, triangle, based on the bases. And then the same thing down here. You can see they're color-coded too, right? So why is, well, we know it's a pyramid. What type? You probably guessed. Triangular, right? Because the base of that would be a triangle. Next thing, reminds me of Egypt, right? Square pyramid, rectangular pyramid, pentagonal, hexagonal, and octagonal pyramid. That's all I have for you guys for today. Just barely 8 minutes. And I'll see you in class.